Here we go. Hello, everyone, and welcome to today's post-conference webinar, Data-Driven Commissioning for Improved Health and Efficiency, presented by Safe Traces, a BCA conference exhibitor. My name is Maria Augustine, and I'm going to be your host for today's session. Please note that throughout the presentation, all phone lines will be muted, and this will minimize any background noise or feedback that could distract from the presentation. You can put any questions you have in the chat, and we'll be addressing them at the end. We'll also be recording the presentation, and it will be available for viewing on BCA's YouTube channel in a few days. I will now turn it over to Safe Traces.
Thanks, Maria. My name is Stephanie. I'm the Director of Channel Partnerships here at Safe Traces, and I want to introduce our speakers today for our talk. First, we have Eric Malmstrom, who is our CEO at Safe Traces. And joining Eric is Wade Conlin, the Commissioning and Energy Discipline Manager for Hansen Engineering. To tell you a little bit more about Wade, he serves as Hansen's Commissioning and Energy Discipline Manager and has over 27 years of commissioning and design engineering experience. He has led retro commissioning on more than 65 million square feet of building around the world. He's active in ASHRAE and is currently a Director at Large on the board. He is also a voting member of SSP PC 300 Building Commissioning and is also the chair of the ASHRAE GPC 1.6 and a voting member of the ASHRAE's Academic Task Force and leading the building readiness team. With that, I will turn it over to Eric.
Thanks so much, Stephanie and Maria, and thanks to everyone to joining today. So we're excited for this webinar. Our brief agenda, Wade is going to kick us off talking about the current challenge and opportunity as it relates to today's topic. Then I'm going to talk us about Safe Traces, commissioning service and technology for indoor air quality, specifically focused on improved health and efficiency, talk through a couple case studies, and then Wade will close us out talking about how this can add value to other commissioning services, organizations and personnel like yourselves. So without further ado, I'm going to turn it over to Wade. Thanks so much.
Thanks, Eric, and thank you, Stephanie, for the too long of an intro. But so the challenge, right? That's what we always face when we're doing commissioning is trying to overcome whatever challenge that is. And the challenge we're talking about today is the health versus efficiency. I also kind of liken it to IAQ versus energy/carbon, depending on where you are on that in that realm. The chart on the right, I love this chart, and the reason is it really gets into that concept of how do I balance energy and efficient energy and IAQ. And so this study done by Stevens and Azimi, they looked at systems and they said, okay, what if we improved just the filter efficiency? And that's the black line that you can see where the MERV ratings go up and start to plateau as it gets up between 16 and HEPA. Or what if we just increase the amount of outdoor air in these systems? And you can see the different lines. They try to pick different climate areas. On the x-axis is annual cost. How much would it cost you to operate, maintain this system with these different variations? On the left, this is where the IAQ comes in, the health and the safety is because it's relative risk of infection, right? Everything is a relative thing. You can never be zero in reality, right? But you can see that as you increase the outdoor air or as you increase the efficiency, you're going to reduce that risk of infection. So it tells you that those are great opportunities to use, but the outdoor air costs a lot more than filtration. But by no means am I saying eliminate your outdoor air, right? If you see the 52% tagline on the left-hand side that you've probably read now, is that indoor air quality risk is attributed to inadequate ventilation 52% of the time. So we still need to have proper ventilation, but it just needs to be properly done. And when you start to look at this, and during the Epidemic Task Force and the Building Readiness Team, when we talked about evaluating systems and then evaluating how you're going to improve those systems, everyone started saying, okay, well, what about energy? What about the energy cost? What is the impact? And so that becomes back to that balance. And so you can see there's a potential increase depending on which methods you go about making your systems provide a safer environment and trying to do it efficiently. Next slide. So if you've got a challenge, there has to be an opportunity to improve upon that and make things better. And so ASHRAE's Epidemic Task Force and other organizations have created a lot of useful guidance material. And in ASHRAE speak, a guide is best practice, and standard means code language. But ASHRAE has accepted the challenge of creating a IAQ pathogen mitigation standard, 241P. And so if it's a standard, that means it's, code enforced language. It's ASHRAE's process of consensus based that'll eventually hopefully become ANSI with this. And this standard is looking to, and you can see it on the bottom left, right? Dealing with design and operation, because you can design something perfectly, but does it operate that way? It's alternative paths to achieving equivalent outdoor air or clean air. And then it does want a full bold item of testing, verification, commissioning, recommissioning. It's one of the things that Dr. Bill Bonfleth, who's been chosen by ASHRAE to lead this standard, really understands greatly, which is you need to be able to understand how your systems are working to be able to understand how to make them better. And then you need to make sure that they are actually working better. So there are other opportunities. Next slide. And this gets into some financial opportunities that are out there, as well as challenges. The first, you can see the American Rescue Plan, and then also the infrastructure law, where there is a lot, billions of dollars set aside to try and help different state, local, tribal governments in terms of nonprofits, community centers, schools, transportation, low-income housing, with the whole focus of improving IAQ. And when you say that, hey, we're going to set aside this money for that, what you really hope is that they're going to improve their IAQ, but they're going to balance that health versus efficiency, or IAQ versus cost. And the item on the right, the Clean Air in Buildings Challenge by EPA. This is kind of backing trying to help make sure that they're backing what's being provided with the billions of dollars. But they actually put out an RFI to try and find out more information. And they were looking to try and figure out best practices to promote awareness, ways to recognize leaders, and how they're improving building ventilation, filtration, IAQ. And then defining quantifiable metrics or targets to evaluate buildings to figure out, are they delivering proper IAQ? So we've got an opportunity to address the challenge. And Eric, I think you can start talking about a way to do that.
Great. Thanks so much, Wade, and great kind of context for the rest of our presentation here. So just by way of quick background, Safe Traces, for those who are not familiar with us, we are a leader and pioneer in actually commissioning that's focused on indoor air quality and a lot of the stuff that Wade was talking about. So our innovation and our breakthrough is developing a tracer technology where we've engineered aerosol tracers that safely simulate and mimic airborne pathogens, things like COVID, influenza, RSV, other infectious aerosols, but using safe materials that can be a challenge method to real-world HVAC systems and air cleaning technologies. This has been years in the making with the support of the National Institutes of Health, FDA, Department of Energy, and Department of Defense. And the roots of this technology go back to biosecurity and the anthrax spore scare we had after September 11th. So there's really a deep rooting of this technology. And the practical value of it is, one, having a way of going into real world buildings and actually commissioning the HVAC systems and air cleaning technologies. But then also beyond commissioning, we have the first and only actual performance-based verification mark for buildings for aerosol removal. And that's something that we offer in partnership with Underwriters Laboratories, or UL, which is a global safety science leader. And the value of that is being able to communicate to occupants of the building that the building has been tested and meets an independent science-based performance level. Beyond safety, savings is critical. As Wade mentioned, indoor air quality has huge implications for cost and energy efficiency. And while we have all these concerns and risks related to airborne respiratory diseases, we also have increasingly code mandated decarbonization requirements and also the need to manage the kind of cost structure of the building. And so our technology is really being used to find the sweet spot between indoor air quality and energy efficiency or health and efficiency. Who we work with is pretty wide ranging. So some of this we'll get into in the case studies, but we work across many different types of buildings ranging from corporate real estate including office, industrial warehouse locations, and then also laboratories and other types of corporate spaces, commercial real estate, education, both higher ed and K-12, and then a variety of government and institutional types of settings like mass transit, prisons, hospital systems, airports, etc. And we work in close partnership with commissioning agents and tab contractors and other engineering service firms, as well as control companies like JCI and Honeywell. We basically use our technology and our platform as a way of adding value to their various services and using us as a way of more accurately testing real world systems to then guide what happens afterwards. This term, indoor air quality focused commissioning, the real meaning of that is being able to not rely on online calculators, to not rely on models, computational fluid dynamic models and existing applied methods that have been used throughout engineering and industrial hygiene for some time that are really not geared towards airborne pathogens and things like COVID. In many cases, we're using things like CO2 or Wells-Riley equations to help guide how we think systems are performing based on their design and the way they're being operated. Where our tracer technology comes in is giving you a more accurate challenge method. And the tracers are engineered to safely simulate airborne pathogen emission, so a respiratory emission of someone coughing or sneezing or breathing, and then understanding where those particles are traveling within an indoor environment, and then how efficiently they're being removed and how they may be recirculating throughout the space. The value of using an aerosol challenge method is that in a single test, we can measure and verify the impact of outdoor air and whether increasing the outdoor air fraction is having a measurable benefit in reducing exposure and containing aerosol contaminants. But then also not just testing that, but in the same test, testing the filtration impact on these particles, and both filtration provided by air handling units, but also local filtration, things like in-room HEPA units, which have become very popular during the pandemic. The test results from this type of testing is linked to things like equivalent air change rates, air balance, and also containment. We can express the data in more traditional engineering type metrics, but then also we can also express the data in more dose exposure levels and understanding, as Wade mentioned, the kind of spectrum of risk of how much particulate is in the air, and then putting that into a red, yellow, green kind of relative risk spectrum to help people understand what the potential risk level is in certain spaces, and then being able to visualize that data in a way that is very intuitive to people and making it in heat maps and things that help demystify air and airflow and particulate levels. We have done quite a bit of research and published on our aerosol-based methodology in places like Building and Environment and other top scientific journals. So we're very serious about the underlying science of what we do. Moving on, just to talk about kind of our platform, which is under the brand name VeriDart. It really consists of three main elements, or three components. The first is a field verification service, So using our aerosol tracer technology in a kind of kit type of setup, we certify and train commissioning agents, test and balance contractors, and other industrial hygienists and folks in the safety, engineering, and facilities management world to use our technology in the field. And our online certification is a half-day course that everyone is required to go through. And once they complete that, then they are eligible to use our technology in the field. To the end user, the building owner and operator, the field verification service is a delivered service. So their building goes through a performance assessment with our certified providers, and using the aerosol tracers and a kind of sampling type of methodology that generates data. That data then comes into the second component of the platform, the cloud-based software platform, where we provide all the analytics and the test results from the buildings that are tested in a kind of software platform that shows both at a portfolio level and then also drilling down to building level and then floors and specific rooms. It allows you to see the results and then show them in more of a dashboard format when you're kind of zooming out. And really the focus of this data is back to, one, confirming that the system safety, and then secondly, helping overlay kind of the energy and cost implications of different strategies, whether you're going to focus on outdoor air, filtration, in-room, HEPA. We basically help run the energy and financial numbers against those strategies, against the performance data. Finally, the third component is a UL verification mark, which is called Verified Ventilation and Filtration. And that's where we take buildings through an annual performance assessment against a standard that we've developed, or a performance target that we've developed with UL, that is based on removing 99% of aerosols within an hour in high density areas of a building. And this is a way, one, to actually take the building through an independent science-based performance assessment, but then secondly, being able to communicate the safety of the systems to the building occupants. The kind of process flow of this testing is, one, kind of doing a desktop audit of a building based on the building design and the way it's being operated, using the ASHRAE's equivalent air change calculator that Wade was actually responsible for developing, and then using that to give us a kind of sense of where should the building be performing, and then also planning kind of which areas of the building are we going to be testing, which then leads into step 2, which is having our certified providers go and test high density areas of the building and emitting our tracers in those spaces, and then over the course of an hour, seeing at what rate they're being removed. That then generates step 3, which is the data. And based on that data, we'll look to see are the spaces tested, and is the building achieving the performance bar set by the UL verification mark? And then if it is, if it's not, identifying deficient areas and helping then figure out what's going on there and how can they be brought up to the performance bar that we set. And then also importantly, in some spaces, they may be overventilating and have an opportunity to potentially adjust their set points where you reduce the cost and energy penalty. And so the optimization can go both in addressing deficient areas, but also potentially dialing back set points in other areas. And then finally, the UL verification mark is the last step of being able to communicate this to the building occupants, and that's an annual verification program. So just quickly to talk through a few case studies and spaces that may be familiar to folks who are listening today. So corporate real estate. We've worked with many corporate real estate operators, and often they're trying to recommission or retro commission or even ongoing commission their HVAC systems against large portfolios of buildings, that span across the US and often internationally. And they're trying to figure out how can we provide a safe environment for our employees, but also do that at the highest cost and energy efficiency. And especially with many of these companies being signed on to ESG, decarbonization and net zero type of commitments. And they also have to manage the costs and the OpEx of their real estate portfolio. It's very important to find that sweet spot. And so for corporate settings, we're often testing areas like training and conference rooms, break rooms. Some corporate real estate have ambulatory care and kind of more healthcare type designated areas within their facilities. And so that's generally the types of spaces that we focus on. And for this particular client, who's a large Fortune 100 company with tens of millions of square feet of facilities, and what we're showing here is kind of warehouses, so million square foot facilities. They basically wanted to know across sites, is there a baseline through the HVAC system? What rate of aerosol removal are they getting? And then when they were looking at enhancements, which were generally increasing outdoor air levels, upgrading MERV ratings from MERV 8 to MERV 13 and higher, and then in high density areas, putting in portable HEPA units, what was the impact of that? And so for this client, we tested multiple facilities. We did seasonal testing for them. And basically what we found was that increasing outdoor air and fan speeds often had a diminishing marginal return, given the size of these facilities, and then also that many of them had high ceilings. Increasing outdoor air was very cost and energy intensive, and also not showing much of a particle removal benefit in many instances. Additionally, local HEPAs were useful in some of the smaller, more enclosed areas with lower ceilings, but they certainly weren't necessary in many other areas. And so that helped guide where they were going to use local HEPAs. And finally, like many commissioning studies, we found that where the facilities should be performing on paper, but based on design and versus performance, were often highly variable, and both within a location and then across sites, things that on paper should be performing at a certain level and should be similar often were very different. And so the value of all this data that we provided through our testing for this client across their portfolio led to $50 million of annual cost savings and nearly 80 million kilowatt hours of energy savings. So we're talking about real money and real energy savings through our data. Next, and I'm just kind of running short on time here, so I'm going to speed up a little bit. Long-term care facilities and healthcare generally. So obviously these are facilities that have risk. You have, in the case of long-term care facilities, elderly people who are often much more vulnerable to respiratory diseases. And you can see that in hospitalizations and mortality rates. So, there's obviously high sensitivity to these types of facilities and making sure that their ventilation systems are working well. So in this case, we worked with affiliated engineers, and then also with the University of Nebraska at Lincoln, and funded by the Department of Energy, looking at how to retro commission HVAC systems, and then also adding supplementary air cleaning and physical barriers to get to acceptable safety levels for infection control. The key risk areas are resident rooms, but also ante rooms and staff and common areas. And in this case, this client was looking to develop a designated quarantine area within their set of buildings. And what we found was that in the resident rooms, standalone HEPA units created negative pressure while preventing recirculation of contaminated air. So, that was good. They also set up ante rooms where we were able to verify that there were effective aerosol removal rates in spaces outside of the resident and patient rooms with only one door open at a time. And then in the staff and common areas, we found that with these types of barriers, and this is not the case with all of them, that they were effective in isolating air with the resident rooms. And so all of this was providing data that they wouldn't have been able to kind of get through traditional test and balanced kind of data, or through just looking at kind of online calculators and other more theoretical ways of understanding the building performance. And this was very valuable because ultimately they were able to help provide a safer environment for the residents. Finally, K through 12 schools are obviously very important now because a lot of the federal funding that's been available via ESSER and some of the other stimulus programs that Wade mentioned are very hot topic. And so we've been working with Atlanta Public Schools, which is a large urban school district with nearly 100 facilities, and they want to, one, understand their HVAC system performance across schools, and then also guide decisions on whether they should purchase and use supplementary air cleaners. And they were able to use government funding to pay for our assessment. And then the data from our assessment was able to help guide further capital improvement and maintenance and operation spending decisions. So their focus were classrooms, cafeterias, staff areas. And what we found was that across schools, unsurprisingly, there was wide performance variation within and across sites. In many cases, recently upgraded HVAC systems outperform their legacy systems, but not always. And we frequently find that recently installed systems are not always checked after they're installed. And so you're not getting the performance that the school district wants. And then local HEPAs were useful in some cases, but they weren't necessary everywhere. And then they were also able to identify low performing sites and then prioritize them for upgrades. So I'm going to turn it back to Wade here to bring us on home and then take some questions. So Wade, please go ahead.
Yeah, so when I look at this and when we talk about it is a lot of times when we're dealing with commissioning, and this is IAQ focused commissioning, as Eric's talked about, is open loop or closed loop control systems, right? And so this test allows you to actually close that loop. You can see the diagram on the right-hand side where it does the full circle. So I look at it as a measuring tape or a performance test in terms of it, right? I can do an integrity test on filters. I can say, hey, I've got the right amount of outdoor air via certified tab technician doing the tab work with certified equipment, right? Calibrated equipment. But then how does that overall system perform? And so I look at this as a tool for me in the retro commissioning world to take it to my projects to say, every time we're going to retro commission a building, there's a lot of spaces that are, whether it's infectious aerosols or it's just odor or other things that go along with it that you're going to have in these facilities, is you can carry the ability to do actual performance testing of how those spaces perform with regards to IAQ. High density, high risk, sample some of those, and you're looking at getting the actual performance testing. My guess is this will tie in somewhere along the way, and standard 241P will start talking, because it talks about how things are actually operating and performing. The next slide shows a performance specification that can be used. Safe Traces and Stephanie put some time into this to develop a way to say, here's how we're going to run a test. Here's how we're going to execute the test. Call it your test script from a commissioning perspective. And so this is a way that you can look at putting it into projects or getting it into requirements to say, yeah, I want to make sure that I have the tools in my tool belt to be able to perform IAQ verification of spaces. Whether you take it to the UL listing level or not, you can actually help your owners by helping identify improvements to spaces where they're having different issues, whether it be mold, odor, anything else that falls under that sun. And so it's a tool that we have in our toolbox to help actually show that the systems that we've looked at and said, yeah, these are meeting the requirements of the ETF, the theoretical side that Eric was talking about, actually perform. With that, I think we're ready for some questions, Eric.
Yeah, and unfortunately, I burned a lot of our time, so I'll turn it back over to Stephanie here. Her email address is listed at the bottom of this slide. So, but go ahead, Stephanie. And if we run out of time here, people should feel free to follow up with her if you're interested in learning more or working with us.
Thanks. Yeah, great job, and thanks everybody for joining here today. Wade, quick question that has come in. How do you see this being used as a communication tool, as a commissioning agent, when you're tasked to try and get your items actioned after you do your assessments?
So if I understand the question properly, is when we get the assessments done, there could be some things in terms of room for improvement, or it's not necessarily achieving what the goal was. That happens with every system within the commissioning process. You are always, I mean, that's why commissioning providers have a job, is because things aren't working the way they're supposed to. And so this just falls under that normal process by which we try and make sure that the team, which includes the contractors and the owner, are working diligently to get those systems working in the appropriate, owner's project requirements, whatever else you want to say, current facility requirements, all the different guides that are saying, here's what we expected our building and system to do. So it's just, creating issues and having discussions with the team to make sure that those corrections are made.
Another question here. Michael wants to further understand the ASHRAE mitigation standard. Has it been adopted? He mentioned that most of their folks follow ASHRAE.
So it is in its infancy. I was actually talking to Bill Bonfleth, who was the chair of the epidemic task force and has agreed to be the chair for this standard. He is there was an open call for applications. He was trying to look at having different realms, and to him, some commissioning providers made sense, and certified TAB technicians, to have that. People who evaluate buildings for a living ought to be a part of this standard. So it's once the project committee is formed, trying to hit a 6-month goal for getting materials created and issued. And he believes, he hasn't set it in stone, that it'll operate a lot like the epidemic task force, but everyone's going to be on the committee, where you have a handful of voting members that led teams, and then you have a lot of other volunteers that are actually taking sections and doing work at a high pace. So it's short answer is no, it has not been created or issued yet, but it is in development, and it needs to be in 2023. So.
And then one last question that I'd answered in the chat, but I can go ahead and answer this. Does the field verification service meet well IAQ testing certification requirements? And yes, you can use this data from these assessments to obtain the WELL certification. It can kind of be a 2-for-1 as well, because you can also obtain not only the UL verified ventilation filtration mark, that data can then also be sent to WELL to obtain that certification as well. I think right now we've finally actually ran out of time. And so we wanted to thank everybody again for participating and joining in on our talk. We really appreciate the BCA community and given the opportunity to present to you all. Hope you were able to take something meaningful from this presentation. Again, if you have any questions, please feel free to email me, Stephanie@safetraces.com. And with that, we will chat with you further and see you at the next conference.
Thank you so much, Eric and Wade and Stephanie. And on behalf of the BCA, I'd like to thank everyone for your participation in today's presentation. Have a great day.
Thank you. Bye.